All right, I did what you're not supposed to do. I built a state management library for React. Yes, another one. Why do we need another one? Why did I go off and build another library when the React ecosystem has Zustand, Jotai, XStateStore, etc.? Well, I tried all these tools and decided to build a perfect blend of all of their strengths. And I want to show you how it's built and how it works. Let's start with an example. Say we have a document editor, and it has both the title and description that are editable. And say you want to combine all these properties into a single unified store so that you can handle file writes or local storage backups more easily. You can model that out with Zustand, which is the most popular option that I've seen around the React community. You can define properties on a store using types and pass that into the create function right here. I have title and content as properties, and then set title and set content as actions. And actions are just stored like any other property inside of a Zustand store. So I've defined the types for those here, and I've defined the implementation using the setter that's passed in by Zustand to safely set different properties. And it'll merge them smartly, which is very convenient. So I could say set title, and it'll leave the content alone if I don't specify that property. Heading over to our app, you can wire these up using the hook. You'll notice back here, we export our stores as hooks. That's the Zustand convention, so that you can use them in React right away. So we've called this use document store, and then you select the parts that you care about out of that store. In this extra little step, make sure that we're only observing parts of the store that this component cares about. So here I have a component that just has the title input, and I'm selecting title and set title to only re-render when those properties change. And I can prove that with a little bit of console logging here. So if I just say title component rendered, yeah. If I start typing in the content box, it's not going to change because we didn't subscribe to the content property. But as soon as I change the title, then we're going to see our console logs come through. So a few powerful primitives are being shown off here. The first one is the ability to select parts out of a store so that you don't have unnecessary re-renders. And the second powerful part is everything is a hook. So you don't have to worry about, am I binding this to React correctly? Am I calling subscribe or some other property? It just is a hook. It is designed for React, which is very convenient. But I do have a few gripes with this. The first one is definitely specifying the type up front for your store. As your store gets more complex over time, it's more difficult to define the type of everything. It's nice if you can just rely on a bit of inference, where if I remove this, it can infer based on the contents of this what the type should probably be. The second issue is co-locating actions onto a store directly. I understand they do this so that they can manage granular updates and handle the object spreading for you, but it is a bit odd that if I ever wanted to mutate a store, I can't just import the store and call .set, the same way that you would on a solid.js signal, for example, or things outside of React. We can't have nice things. We need to have this very explicit action to grab the function out of the store and then call it down here. It's a minor gripe that kind of piles up over time the more complicated the store gets. I guess I'm looking for something a little bit more like Jotai, which is actually a library made by the same guy who made Zustand. And it's a little bit simpler. Down here is a Jotai store. You create one by calling the atom function, and you just put in the properties that you want. No need to add any actions. It'll just infer the type of the store, and if you want to operate on that store, you can call the useAtom hook. And this is a lot like useState in React, where it gives you both a getter and a setter in order to mutate that store. And you can see here we're mutating the whole document and just spreading along any properties that we don't care about, and we're reading in document.title. So this is very convenient. Now we have a global store for our document that's a little bit nicer to maintain, but we do run into the issue of updates, right? Because now we're just subscribing to the whole document everywhere in our app. So if I start editing the title, you'll see that that updates, but if I start editing the content, the title's gonna re-render. And so is every other part of the app that cares about the document. Now, there is a way around that problem. You can subscribe to specific parts of a store by creating an atom from other atoms. So here you can call the atom function again, and use get in order to get a specific property and then drill into it. It's like a selector, but to be honest, kind of cumbersome. I didn't know this even existed until Cursor suggested it to me. But the more you know, there is a way to be granular about these stores. And then set documents the same way. I'm calling use set atom, so that way it only renders the setter. Now we're getting very, very in the weeds for something simple, but hey, that's how you do it. Then you can bind in the title because you only selected the title. You can call set document as you would before. And you can see here, if I edit the content, the title no longer re-renders. So, cool. There are ways around it to make Hotai efficient as well. But in my opinion, this is a little bit cumbersome to remember, and it's also not something super well documented that you can get subparts of a store. Basically, if you have a large store that your whole document depends on, they steer you towards Zustand, which has the problems that I discussed earlier. So this begs the question, is there some possible way to meld these two worlds? Is there a way to not ask yourself, which library am I supposed to use? Just have one solution that is as granular as Zustand and as simple to get going with as Jotai. That brings me to Simple Stack Store. So let's create our document store again. Document store. And to create a new store, you can call the store function. This has some nice inline documentation to see how it works. And it's coming from the Simple Stack Store package. And this is the only thing you're ever going to import when you're using Simple Stack Store, which is so nice. So here I'm going to create our store, and I'll just put in the values directly. As you would expect, there is type inference here, so we just have a store with title and content. So how do we get values out of the store? Well, that's also pretty simple. If we look at the type signature for a store, you see a few properties available. You can call .get to get the value at any given time. You can call select, which we'll get to in a moment. We have set, which sets the value, and also subscribe, which is what a React hook uses to re-render your components, and a function that you can use if you need to subscribe to events for logging, local storage, whatever you want to do. So if we wanted to have a utility function to set the title, for example, we could call set title, and that's exactly right. We can call documentstore.set, we can spread the old values, and we can pass the title in here. Now let's wire this up in our application. To get the value out of a store, you can call the useStoreValue hook. This is going to get the value and also call .subscribe internally to re-render your component whenever the store changes. So I can import document store right here, and the value on the other side will be the type-safe document. So in here I could just say document.title, and on change we can just call the setTitle function that we had earlier. We also could just call documentstore.set directly in line, but because we wrote that utility function, let's go ahead and use it. Now we'll update our content function to do the same sort of thing. We'll call document, we'll get the content, and then we'll call the set content utility that we wrote. Now if we head to our application, you can see everything is updating as you would expect. But of course, you've probably noticed we're subscribing to the whole document. Isn't that the problem you mentioned earlier? Well, it certainly is. If we go ahead and manipulate this, you'll notice as I change the content, the title component and every other component subscribed to the document is going to re-render. We need a way to select nested values. In Simple Stack Store, it's as simple as calling .select. Watch this. So if I use the select function, this is going to let me select what part of the store I care about, with type safety, by the way. So I can choose the title property, and now instead of document, this is just going to be the title. Nice. So now I have access to just the title right here, and as I change the content, it's not going to re-render. As I change this, let's add our console log back in here. There we are. You'll notice, yep, not changing. Sweet, so now we have granular updates on our store values. And if you're wondering how this little bit works, I actually have this video that the whiteboard guy sent me right here. Let's go ahead and click into that. Let's understand Simple Store on a technical level. Say we have an example here, it's an object with a title, a body, and an author. If someone subscribes to that store with a React hook like useStoreValue, that's gonna call .subscribe under the hood, which is basically gonna tell React, please update every time subscribe gets called. Here's the implementation for it. It's pretty simple. So that means if we called useStoreValue with the whole store as an argument, every time we set the title, subscribe gets called and the component re-renders. We set the body, subscribe gets called and the component re-renders, and so on for any change to the store. But what if we care about just one of the keys, like subscribing to the title property? Well, that's where we call .select on our store to say what key we care about. This returns a new subscribe function with a little conditional check at the top. You can see the code for that here, where we track the previous value at that key, so the previous title in our example, and we check if the old and new values are the same. If they're different, we're gonna notify you on that subscribe function you passed in. Otherwise, we'll just throw away the update. I like to think of this as a set of doors. So when you start your application and you set the initial values, all the doors get opened up to render those initial states to your browser. Then if we update a key in our store, we need to knock on every door in our application to check if the value has changed. If the value is the same as last time, we close the door and avoid re-rendering that component. But if it changed, then we open the door and let that update through. Now yes, if your store is very big, that could mean a lot of checks that we need to perform, so break your store up into smaller pieces if you can, but I feel like that goes for all state management libraries. Man, what a nice explainer. He has a nice pair of glasses too, I should really go get those. Now, you might think this is the end of our journey, but we can actually make our app even simpler than this. Watch this. So over here, we have our setters, and they work how you would expect in any other store, where you call .set, you spread the old values, and then you apply the new value that you want to render. This is totally fine, but in my opinion, it can get a little bit messy as soon as you start adding nested objects. So here I've added a nested property for author inside of this meta field, and if we wanted to have something for set author, it would look a bit like this, where you have to spread the store, then spread store.meta, and then apply the author. I mean, it's fine, but it gives me flashbacks to the Redux stores that I used to write back in 2017. I would like something that's a little bit simpler than this, and it can be. So, if we wanted to set the title, for example, we don't actually have to call set on the document store. We can select the part of the store that we want. So when we called select earlier, I'll take you back over here, we were passing it straight to use store value, so you couldn't really tell what the type signature was. But if we actually inspect what this is returning, you'll notice it's returning a store. Whoa, so this is a store with the title string, similar to how this is a store with all of the object properties. And on this store, you have all the same properties available to you. You can call get to get that specific title. You can call set in order to set just the title. You can subscribe to just the title, or you can select even further if it happens to be a nested object. So in this example on title store, we could just call title store.set title. And if we wanted to one-line this, we totally could. We could just say document store dot select the title and then set the title. Same thing goes for content. We could select the content out and set that property. And if we wanted to set the author, you can chain multiple selects together. So I'm gonna call select the meta property, select again on the author property, and finally set the author. Oh man, so nice. If you've ever used things like lenses, if you've used Ramda or Solid.js or any of the more exotic state management solutions, you're probably familiar with something like this, where you might say lens into the meta.author property, and then only set that granular part of the store. So now we have these setters that are even simpler for us to use up here. And you might imagine, hey, I actually don't need any of these setter utilities. Now that I know I can just select part of a store, maybe we just kill all of these things. Instead, just do it like this. Export const title store, content store, author store, and then call .set directly from our components. So over here where I'm selecting the value, let's go ahead and just import the title store directly. And then there is the title. And if I ever need to set the title, I can call title store.set. So now I don't even need actions. I can just select parts of the store and mutate them directly from my components. Nice. So here I can do the same thing with the content store. So there's the content. We're going to grab that out, content store.set. And as you can see, these utilities are very tab completion friendly if you're worried at all about using a new library with LLMs. And just to prove the point, I'll go ahead and add some console logs to make sure everything is still rendering how we would expect. So you can see here as I edit the title, it's going to render out the new title, but not the content component. Same thing goes as we're editing our content component. So nice. So not only are we making it easier to select nested values to read, you can also select nested values to write. So that way you don't have to deal with object spreading if you don't want to. Now for a practical example of where I've applied this in my work, I'm building this notes app over here called Hubble. And I wanted a way to track all of the projects and notes that exist inside of this notes app. in order to model that, I just created a store for my entire application. I could, of course, break this apart into granular stores if I wanted to be a little bit smarter about how the signals are subscribing and all of that. But as I was just scaffolding this out, it made sense to have one big store for everything. So I have my projects, which is a record from the ID to the project. And you'll notice that they also have a set of notes inside of that project, so a deeply nested document structure here. We have our current project ID, which I read out of local storage on startup. And then we have is bootstrapped, which is an async operation to populate all the projects from your file system. And down here is where I'm actually updating that store. I was doing a bit of debugging earlier, but you can see if we wanted to set properties on the store, for example, I can load all the projects from my database. I'm storing the list of user projects in SQLite. And then for each project, I can generate the ID. I can select just the ID out of the project store, which is so cool. So project store has a type record string to project, and then I can select the ID out of there to get a reference to just that specific project and set that property if I want to. So now inside of here, we ramp through all of the notes, we reduce them down, and then I can call project store.set and then put all the properties onto it. In fact, I could simplify it even further if I wanted to avoid this spread operation, but I decided this was fancy enough for now. Here's the application running just to show you what I mean. You can see that because we have this store globally, we can update any part of the app in real time as we update that project's store. So here I'm changing the contents of the note, which is going to recompute the title, which is going to tell anyone who's subscribed to the projects array or the notes array here to re-render the title. So you can see that's updating over there in real time. Super freaking nice. Now, the last thing I'll touch on is optimistic updates and async, because when you're dealing with stores like Simple Stack or anything else, you'll probably deal with operations that don't finish right away. You need to figure out what do you show the user in the downtime. Now, that's not something Simple Stack manages for you, but I have found a pattern that I like using with Simple Stack Store. It's probably worth sharing. So I'm building a Notes app, right? And every operation needs to be persisted to the file system, which is an asynchronous thing to do, even though it is pretty fast. So you can see here my add note function, for example. What I want to happen is whenever you hit the add note button, right here, it creates a note right away so you can just start typing. And then in the background, it also creates the file on the file system, so all of your updates write to that file. And you can see here I'm creating an ID. I'm grabbing my note out of the note store, specifically selecting by the ID, so that way I can just call .set on the note when it's ready. I create the new note. I set the new note right away, optimistically, and I return the ID so I can redirect the user to that new note. So the main thing to highlight is this queue. Why am I just using a queue? Why am I not just using a wait? Well, if you think about all the operations you can do, it is pretty important that they happen in order. So for example, what if I were to quickly add a note, update that note, and then delete it? If we just make all of these async promises that we don't wait on to finish, it's very possible that you add a note, you update that note, and then the add note didn't actually complete yet. You try to call an update on a file that has not been written. And then you would, of course, get an error saying file doesn't exist, we can't update because we didn't wait for add note to finish. The only way to ensure that is to make sure one operation is happening at a given time. And that's exactly what queues are designed to do. Shout out to PQ, which is kind of the gold standard in JavaScript for managing queues. I'm using it on the front end because it totally works in the browser. And I'm saying you can only run one thing at a time on this queue. So every time that we do an operation, I'm going to put it onto the queue instead. So when you call add note, we're going to queue an add note operation. Whenever you delete a note, we're going to queue that as a delete operation. And update, same sort of deal. That way, all of these operations happen in the order that they were called. So you would add a note, it updates the UI right away, and then it queues this up so that if you call update, for example, that will not run until the add operation is finished. So that's the way I would encourage you to manage async with Simple Stack. Try to figure out what your optimistic update should be and queue updates so that they happen in order without having to wait on them in the UI. All right, so if you want to try this out, you can go install it at @simplestack/store. You can also go to simplestack.dev in order to get some nice looking documentation. I'm going to fill this out with some guides to make it a little bit easier to walk through, but this video is hopefully going to be a good reference. And if you want to contribute, of course this thing is open source. We put the source code at the top of the doc so you don't miss it. And there's so much work that we probably need to do. There's no performance benchmarks. There's no optimizations. There's no unit tests. All I have is a set of docs and an index.ts file in a dream. The entire library fits into 220 lines. But I feel like it was at a point where I did everything I wanted to do. I'm using it internally and it works for my purposes. So let's get it out in the open to see who else wants to use it. So go check out the source, get in the comments, get in the issues. See you in the next one.